Building a house on land is already a complicated process, but building a house that can float on water is a completely different challenge. In this project, one man decides to build his own houseboat, a home constructed directly on top of a boat hull. But this is far more than simply placing a small cabin on a deck. He must deal with three critical engineering factors at the same time: buoyancy, stability, and structural load. In this video, we will follow how he gradually builds a real floating home, from the base structure and framing system to the methods used to control weight and maintain stability. When done correctly, this isn't just a house, it becomes a floating structure designed to live on water for years. Welcome back to Quantum X. The framing of the houseboat begins to take shape. The man assembles the wooden members into the main structural frame of the floating home, fastening them with screws wherever the joints are easy to access. This provides a quick and reliable way to hold the structure in place during assembly. But not every joint can be reached with a drill. In tight corners and hidden areas, he switches to a different technique: epoxy combined with hardwood dowels. Once cured, the epoxy creates a bond that behaves almost like a solid piece of material, making it well suited for the damp and constantly moving environment of a boat. Before the epoxy sets, tie-down straps are used to keep the frame straight and properly aligned. It's a simple but highly effective method when dealing with long structural members. Instead of measuring repeatedly with a tape, he also creates measuring sticks from scrap wood. These allow him to replicate critical dimensions quickly and consistently, an old workshop trick often used in both carpentry and boat building. With the frame stabilized, he begins installing plywood panels over the boat's structure. This step is not just about covering the frame. The real goal is to create a flat and consistent surface that will support the next stages of sealing and finishing. As the panels go on, he also takes time to correct small imperfections in the wooden surface, making sure each sheet sits tight against the frame without creating weak points in the structure. To keep the edges of the plywood aligned, he temporarily uses a flat steel bar as a straight guide. Once the epoxy cures and the panels are locked in place, the steel piece is removed to save material and reduce unnecessary weight. Instead of nails, the plywood sheets are fastened with screws, which provide stronger connections in a structure constantly exposed to vibration and movement on water. He chooses GRK Torx head screws, which can be driven without pre-drilling and significantly reduce the risk of splitting the wood. Once the panels are secured, he injects epoxy mixed with high-density filler into all structural seams. The mixture is applied using a reusable caulking tube, allowing controlled and efficient application. To smooth the epoxy, he simply runs a gloved finger along the joint, shaping the material precisely. Once cured, these epoxy seams add significant stiffness to the roof panels and the overall hull structure. The boat itself is relatively compact. It measures about 8 feet 9 inches high, 20 feet 7.5 inches long, and 8 feet wide, a practical size for a small but livable houseboat. At the bow of the boat, he installs the final triangular plywood panel, closing off the front section of the structure. Pieces like this are often more difficult to fit, since the angles must align with several framing members at once. Once the panel is secured, he continues working with epoxy mixed with high-density filler. The compound is used to fill screw holes and seal the gaps between plywood sheets. Instead of cutting every wooden panel with extreme precision to eliminate all gaps, he takes a more practical approach: allow small gaps and fill them with epoxy. This method saves time, reduces wasted material, and ultimately creates a smoother and more continuous surface once the work is finished. In modern boat building, epoxy fillers often act as a fairing compound, helping level the surface and remove sharp transitions between panels. After the epoxy has fully cured, he begins sanding the entire surface. It's a slow and repetitive job, but an essential one. Without proper surface preparation, the waterproof coatings and protective paint applied later won't bond evenly and may compromise the durability of the structure. Next, he begins building a roof hatch, a small access door that allows ventilation and makes it easier to reach the roof for maintenance. Instead of installing a pre-made unit, he builds the hatch himself, using a simple wooden frame covered with plywood. This approach allows him to control both the dimensions and the weight, an important consideration for any structure built on a boat. The most challenging part is matching the slope of the boat's roof. The hatch must follow this angle precisely, so that when it closes, it sits flush with the surrounding surface and prevents rainwater from entering. To ensure durability, he reinforces the top edge of the hatch in order to install a stainless steel piano hinge. This type of hinge distributes load evenly along the entire edge, reducing stress on individual points, an advantage in structures exposed to constant movement and vibration. Finally, all edges of the hatch are sealed with epoxy, creating a fully waterproof barrier around the exposed wood fibers. It may seem like a small detail, but without this protection, moisture could penetrate the wood and eventually cause swelling and structural deterioration over time. He begins by cutting an opening in the roof for the ventilation vent. However, the challenge lies in the shape of the roof itself. The surface is slightly curved, while the base of the vent requires a flat surface to seal properly against water intrusion. To solve this, he installs thin plywood shims around the vent opening, gradually building up a flat mounting surface. This is a common technique in both boat building and roofing when equipment needs to be installed on curved structures. These shims are then bonded in place with epoxy and fully sealed, ensuring that no moisture can penetrate into the wood layers below. Once the epoxy cures, the area becomes a solid waterproof mounting platform, ready for the installation of the roof ventilation system in the next stage.
To access the roof hatch, he needs to design a safe and practical way to climb up. Mounting steps directly onto the wall would require about 4 inches of depth per step, which would quickly consume valuable interior space inside the cabin. Instead, he chooses a more efficient solution, integrating the steps into the wall itself, creating a set of built-in recessed stairs. This approach saves space and gives the interior a much cleaner, more refined appearance. He prepares 5 steps at once, then builds support frames between the wall studs where the steps will sit. The corners of each step opening are rounded using a 5-inch hole saw, which reduces stress concentration and gives the openings a smoother shape. Before closing the wall, he installs insulation inside the framing. A plywood panel is then fitted over the wall, creating a base layer where the steps can later slide precisely into place. Because the openings have rounded corners, small gaps appear around the edges. To solve this, he cuts small curved filler pieces, mini arches, to close those spaces. Since the wall frame is more than 2 inches thick, several layers of wood are laminated together and then sanded to achieve the final shape. Finally, the outer edges of the steps are rounded over to prevent bumps and injuries, especially since the area sits close to the seating space. Interestingly, the steps are bonded using epoxy only, no screws at all. With enough bonding surface, epoxy alone can create an extremely strong structural joint, more than capable of supporting regular use over time.
With the steps installed, he begins sealing the wood with epoxy. In plywood construction, the exposed edges are particularly vulnerable since the layered veneers can absorb moisture quickly if left unprotected. To prevent this, he applies pure epoxy to seal all plywood edges, creating a waterproof barrier that penetrates and protects the wood fibers. For the rounded interior corners of the recessed step cavities, he switches to epoxy mixed with a lightweight filler, West System 407. This filler is specifically designed to sand much more easily than high-density fillers, making it ideal for surface finishing work. Once the epoxy cures, the next stage is extensive sanding to achieve a smooth and consistent surface. Several tools are used for the job: a random orbital sander for larger flat areas, and sanding discs mounted on a drill for tighter spots. However, the narrow corners inside the step recesses remain difficult to reach. To solve this, he builds a small homemade drum sander using simple parts, a socket head, a bolt and nut, and a strip of sandpaper secured with spray adhesive. Mounted onto a drill, this improvised tool works surprisingly well, especially for sanding tight corners where standard tools simply cannot reach. With the shape finalized, he decides to apply a test coat of paint to the steps. 2 coats of acrylic latex primer combined with a sealer are applied. This is not the final paint color, but simply a way to preview how the form and surface will look once the project is finished. The result looks impressive. The recessed staircase appears clean, solid, and well integrated into the wall, even though the process clearly required more work than originally expected.
In a houseboat, insulation is not just about staying warm during colder weather. It also helps stabilize interior temperatures and reduce condensation, which can easily form when warm interior air meets the cooler exterior environment. The insulation panels are cut to fit tightly between the wall studs, filling each cavity completely. Properly filling these spaces helps limit unwanted airflow and improves the overall thermal performance of the structure. Once the insulation is in place, he begins installing plywood paneling over the front wall framing. These panels serve not only as the interior surface of the wall, but also as an additional structural layer that stiffens the frame. In lightweight wooden structures like this houseboat, paneling often works similarly to a shear panel, helping the wall resist movement and vibration as the boat shifts on the water. As the panels are secured, the forward section of the cabin begins to look more like a livable interior space rather than just an exposed wooden framework.
Next, he begins designing a compact bathroom area inside the cabin. In a houseboat where space is limited, every element must be planned to maximize efficiency while allowing easy maintenance later on. Instead of placing the fixtures directly on the main floor, he builds a raised floor system. The surface is covered with 1/4-inch plywood, which is light but still rigid enough for this type of application. What makes this design interesting is that the plywood is not installed as a single large panel. Instead, it is divided into multiple smaller sections that fit together like puzzle pieces. This approach allows individual panels to be removed easily whenever access is needed. The space beneath the raised floor will house the water tank and the pump system, 2 essential components for the boat's plumbing. By placing these utilities under the floor, he keeps the bathroom area clean and uncluttered while still ensuring that the equipment remains accessible for inspection or future repairs.
After completing the bathroom section, he returns to the mid-floor area of the cabin to continue installing insulation and interior paneling. The insulation panels are carefully fitted between the framing cavities, ensuring there are no large gaps where heat could escape.
On a houseboat, controlling temperature and moisture is particularly important because the temperature difference between water and air often leads to condensation inside the structure. Once the insulation is properly installed, he begins covering the area with plywood paneling to close in the mid-floor section of the boat. These panels provide not only an interior surface, but also additional structural rigidity to the hull framing. Next, he moves to the rear wall of the cabin, located at the stern of the boat. The entire surface is thoroughly sanded to remove uneven joints and surface imperfections before painting. Finally, he applies a coat of white paint to the rear wall. The light color helps the interior feel brighter and more spacious, while also reflecting natural light more effectively, an important advantage in compact living spaces like a houseboat. Once the white paint on the rear wall of the boat has fully dried, he moves on to installing a sliding door at the stern entrance. Rather than using a pre-made door, he designs and builds the entire door himself so it fits perfectly with the dimensions and character of the houseboat. The frame is constructed from wooden strips arranged into a grid, creating a structure that is both lightweight and structurally stable. Inside the frame, he installs a layer of insulation, which helps reduce heat loss and improves temperature stability inside the cabin. A small glass window is intentionally left within the frame, allowing natural light to enter the interior while still providing a view toward the rear of the boat. Once the insulation is in place, the surface is covered with thin wooden slats. These slats serve two purposes. They help secure the insulation while also adding a decorative layer that enhances the handcrafted appearance of the door.
After installing the wooden slats on the door, he begins sanding the entire surface to remove sharp edges and create a smooth finish before applying any coating. Once the surface is properly prepared, he applies a coat of clear protective varnish. This finish not only enhances the appearance of the wood, but also protects it from moisture and temperature changes, which are constant factors in a marine environment. A small but practical detail is the cotton strip attached along the bottom edge of the door. This soft strip acts as a dust seal, helping prevent dust, wind, and small debris from entering through the door gap while the boat is in motion. Finally, he installs the sliding rail system onto the doorway frame. The rail is a critical component as it determines how smoothly and reliably the door will operate. With the track properly aligned and secured, the sliding door is ready to be mounted and put into service, marking another step toward completing the cabin interior. With the sliding door installed, the rear section of the cabin begins to form a clear transition between the interior living space and the outdoor area at the back of the boat.
Next, he continues installing insulation throughout the boat's framing, covering both the walls and the ceiling of the cabin. The foam insulation panels are carefully cut to match each framing cavity. When installing them, the key requirement is that the foam must fit tightly within the wooden frame, minimizing air gaps. Even small pockets of air can significantly reduce the overall insulation performance. Once the wall sections are complete, he moves on to insulating the ceiling. The process is similar to the walls, but before closing everything with interior panels, he needs to ensure there is enough wood framing behind the surface to provide solid nailing points later. An interesting detail appears here. Earlier in the project, he made several extra curved frames, arches, beyond what he initially needed. At the time, it seemed unnecessary, but now those pieces fit perfectly and speed up the ceiling installation. To keep the foam panels from falling out while working overhead, he installs small wooden blocks that temporarily hold the insulation in place. Between the foam insulation and the future interior paneling, a small air gap is intentionally left. This narrow space will later serve as a routing cavity for electrical wiring throughout the cabin. It's a small design choice, but it reflects a practical construction mindset, especially important in compact builds like a houseboat. At this stage, he begins installing the interior panels to close in the cabin walls and ceiling.
Instead of cutting the panels beforehand, he first secures the plywood panels firmly to the wall framing using screws. This keeps the panel perfectly aligned and prevents movement during the cutting process. Once the panel is fully fixed in place, he cuts directly along the edges of the window frame behind it. The wooden frame essentially acts as a natural guide for the cutting tool, allowing the cut to follow the exact outline of the opening. With the two large openings now cut out, the cabin begins to receive much more natural light, while also opening the interior space to the surrounding water outside.
The panels are secured using 18-gauge brad nails, which allows for fast installation while minimizing the risk of splitting the wood. The material used is quarter-inch underlayment plywood. This type of plywood is lightweight and has a smooth surface, making it well-suited for small structures like a houseboat, where weight matters.
Each panel is carefully cut to match the exact spacing of the framing, ensuring that both ends of the panel align precisely with the wooden studs behind it. This detail is important because the panel edges must sit directly on the framing in order to be securely screwed in place. If a panel edge does not land on the framing, the connection becomes weaker and the panel may flex or vibrate over time, especially in a boat where small movements are constant. For that reason, he measures and trims each panel so that every edge lines up with a structural member, guaranteeing that there is solid backing for the screws. Once the panels fit tightly within the framing grid, the interior sheathing begins to act as an additional structural layer, helping stiffen and stabilize the cabin walls.
Before closing everything, he also drills holes through the rafters to prepare for electrical wiring. Only a few wires will run directly behind the panels, while most of the wiring will later be hidden behind cabinets and decorative trim. However, when installing the panels on the ceiling, a small issue appears. The plywood sheets slightly sag between the roof rafters. On the walls, this is not a major concern, because many furniture pieces and fixtures will eventually be mounted there, hiding minor imperfections. But on the ceiling, the surface remains fully visible, so even a slight deflection can become noticeable. To solve this, he installs additional narrow wooden strips across the rafters, creating extra nailing points and better support to keep the panels flat. Finally, the entire interior is coated with 2 layers of white paint. The bright color helps hide the natural imperfections of plywood, while also making the small cabin interior feel brighter and more spacious. The panel seams are still visible for now, but they will eventually be covered with trim pieces once the final interior layout is decided.
Next, he begins installing the cabin's heating system using a Dickinson Newport wall-mounted diesel heater, a model commonly used on small boats because of its compact size and reliable heat output. The chosen location is the rear wall of the boat. Positioning the heater here allows the warm air to circulate naturally along the length of the cabin, helping distribute heat more evenly. However, because a sliding door is installed nearby, an additional structural adjustment is needed. He builds a small partition frame made from steel, creating enough clearance so that the sliding door can open fully without interfering with the heater. This partition also serves another important purpose. It provides a solid mounting surface for the heater and supports the heat-resistant insulation behind it, protecting the surrounding wall structure. Above, in the ceiling, he cuts an opening to install the exhaust chimney for the heater. In diesel heaters, the flue pipe is critical because it carries combustion gases outside while creating the natural draft needed for proper burning. By routing the chimney straight upward through the ceiling, the exhaust path stays short and efficient, reducing bends that could restrict airflow. Because the roof of the boat is curved, installing the exhaust pipe for the heater cannot be done the same way as on a flat roof. To solve this, he uses a method similar to the one used earlier for the roof ventilation opening. A circular wooden mounting frame is built and installed so that it protrudes slightly above the curved roof surface, creating a flat and stable base for the chimney pipe. This detail is important because if the chimney base were mounted directly on the curved roof, the contact surface would not seal properly, leaving gaps where rainwater could easily seep into the structure. Once the wooden frame is secured in place, he installs the heater's exhaust pipe through this raised mount. The entire joint is then carefully sealed with waterproof sealant, preventing any water intrusion. Small construction details like this often determine the long-term durability of the structure, especially in a marine environment where water exposure is constant. With the chimney pipe installed through the roof, he proceeds to finish the safety details around the diesel heater installation. At the point where the chimney runs close to the newly reinforced wall, he installs a sheet of heat-shielding steel. This metal plate acts as a thermal barrier, protecting the surrounding wooden structure from prolonged heat exposure when the heater is running. Where the chimney passes through the cabin ceiling, an additional layer of high-temperature insulation is installed. This detail is critical because chimney pipes can reach significant temperatures, and proper clearance from combustible materials like wood must be carefully maintained. He also installs rubber gaskets along the cut edges of the steel panel used around the heater wall. These gaskets serve two purposes. They cover the sharp metal edges for safety and give the installation a cleaner, more finished appearance. These finishing steps ensure that the heater system is not only functional, but also properly protected against heat risks, which is especially important inside a compact wooden structure like a houseboat cabin. Next, he begins building the staircase that leads up to the bow section of the boat. Before cutting any wood, he uses two levels to determine the total rise and total run of the staircase. Based on these measurements, he decides to build 3 large steps, which provide a comfortable climbing angle while keeping the staircase compact. With the basic dimensions defined, he starts building the stair frame. A step template is first created to verify the correct cutting angles and the dimensions of the framing members.
For the structure, he uses a reclaimed piece of Douglas fir lumber. This species is widely used in construction because of its strength and reliable load-bearing capacity, making it well suited for structural elements like stair framing. Once the angles and measurements are confirmed, he assembles the complete stair frame and installs it in its final position inside the cabin. In a compact houseboat interior, stairs must not only be strong, but also efficient in terms of space usage.
While assembling the stair frame, he does not rely on screws alone. Instead, the structure is built using a combination of wood glue and screws. Before fastening the pieces together, he applies a layer of wood adhesive to the contact surfaces. Once cured, the glue creates a strong bond across the entire joint area, allowing the wooden components to behave like a single structural unit. The screws are then installed to clamp the pieces tightly together while the glue cures, while also providing additional mechanical strength to the frame.
The next step is preparing side panels for the staircase, which will cover the structural frame and give the staircase a clean, finished appearance. However, this task is not straightforward because the hull of the boat has a curved shape. The panels must therefore be carefully traced and shaped to match the curvature of the hull, so they fit perfectly against the structure. He repeatedly marks, trims, and test fits the panels until the edges follow the curve precisely. This step requires patience, since even a small misalignment would leave visible gaps along the joint. Once the panels fit correctly, he places insulation inside the cavity around the stair structure. This insulation helps reduce heat loss and limit condensation inside the hull area. Finally, the panels are installed to close off both sides of the staircase, concealing the structural framing while creating a clean, finished surface for the passage leading toward the bow of the boat.
For the stair treads, he uses 3/8-inch marine-grade plywood. To strengthen the edges and improve the appearance, he installs solid wood trim pieces around the plywood panel. These trim pieces serve several technical purposes. They flatten the plywood panel, increase the rigidity of the step, and protect the exposed edges from damage over time, while also giving the tread a cleaner, finished look. With the structural part finished, he moves on to the decorative surface of the step. Instead of using a single board, he glues hundreds of small wood pieces onto the surface, a total of 389 individual pieces. The process is repetitive, cutting, sanding, gluing, and carefully positioning each piece so they fit tightly together. It's meticulous work and takes considerable time, but the result is a striking wooden mosaic surface, adding both durability and a unique handcrafted detail to the staircase area.
After all the wooden mosaic pieces are fully installed on the stair surface, the next step is sanding the entire area before applying the clear finish. Once sanding is complete, the wood becomes smooth and uniform, ready for the protective clear finish, which will enhance the wood grain while also improving moisture resistance and durability for the stair area.
The top of the staircase is designed to be more than just a step. He builds a stair tread with an internal storage compartment, allowing the space beneath the step to house batteries in the future. In small boat design, weight distribution is critical. The stern already carries significant load from the outboard motor, fuel tank, and water tank, so placing the batteries closer to the bow helps balance the overall weight of the boat. Inside this houseboat, the total floor space is only about 120 square feet. In such a compact area, designing a comfortable sleeping arrangement becomes a serious challenge. A fold-out sofa bed is rarely comfortable for long-term sleeping, but installing a permanent double bed would consume most of the available living space. His solution is a ceiling-mounted lift-up bed. When not in use, the bed raises close to the cabin ceiling, freeing the entire floor area. When lowered, it still allows movement through the cabin and access to the bathroom. Instead of lifting straight up, which would block the walkway, he designed the bed to move along a 45-degree path. As it lifts, the bed also shifts backward about 3 feet. The bed frame itself is built from reclaimed wood, featuring an outer frame, structural slats, and a hollow center beam for added rigidity. The complete moving structure weighs around 110 pounds, including simulated mattress weight. After testing gas struts and several powered solutions, he ultimately chose a simpler mechanical approach, a wooden steering wheel connected to a pulley system, cutting the lifting force roughly in half. For safety, the system also incorporates a recycled Toyota Sienna seatbelt, which automatically locks to prevent the bed from falling if something fails. The result is a compact mechanical lift bed system, space-efficient, manually operated, and engineered for safety inside a small floating home.
Once the lift bed mechanism is working properly, he begins installing the final safety and functional components. To lock the bed in place, he installs pole latches that secure the bed in both positions, fully raised and fully lowered. This prevents unwanted movement when the boat shifts or rocks on the water. He adds a support bar to hold the bed securely when it is lowered. This brace helps transfer part of the load from the bed and occupants, reducing stress on the linkage and pulley system. In this design, the metal brackets and linkage arms of the bed mechanism are arranged so they only allow movement along a specific path. This means the system has very little freedom to move sideways. The bolts at the joints are not tightened excessively, allowing the mechanism to move smoothly during lifting and lowering. However, once the front locking latches are engaged, the entire bed frame becomes securely fixed in place. As a result, even when the boat is moving on the water, the bed remains stable and does not swing side to side. One clever addition is a strip of LED lighting mounted under the bed frame. When the bed is raised, the underside effectively becomes the ceiling light for the living area below, eliminating the need for additional overhead fixtures.
Next, he begins building the frame for the bathroom area inside the cabin. Since this wall is not load-bearing, he uses smaller wooden strips measuring 3/4 inch by 1.5 inches. This approach helps keep the overall weight of the boat down while still providing enough structure to support the wall panels and finishes. With the frame in place, he moves on to building the bathroom door. The door is made from reclaimed cedar boards about 1/4 inch thick. This is the same material previously used for the sliding door at the back of the boat, helping maintain a consistent look and material palette throughout the interior. After assembling the door, he sands the surface and applies a clear protective finish, which highlights the natural cedar grain while also improving moisture resistance inside the cabin. Finally, the door is installed onto the bathroom frame, completing another key element of the compact houseboat interior. Because the bathroom space is very limited, no off-the-shelf shower pan would fit, so he decides to build a custom shower base from scratch. The base is made from 3/8 inch plywood. The drain hole is drilled slightly off-center to avoid a structural floor beam underneath. Below the drain, he cuts a larger recess cavity to create space for the drain assembly. To ensure proper drainage, the floor needs a slope toward the drain. While the standard slope is 1/4 inch per foot, he doubles it to 1/2 inch per foot. This slope is created by installing multiple wedge-shaped wooden pieces beneath the base, gradually directing water toward the drain. Once the shape is complete, the entire surface is sealed with a layer of pure epoxy, allowing the resin to soak into the wood and fully seal the grain. To strengthen the structure, the shower base is reinforced with 2 layers of fiberglass mat across the entire surface. After curing, the surface is sanded to create a good bonding texture. He then applies an epoxy filler that is easier to sand, repeating the coat and sand process about 3 times to smooth the surface.
Next comes gap filling and waterproof fillets. He mixes epoxy with West System 406 colloidal silica, creating a thick peanut butter-like mixture used to fill joints and create rounded corners, which improves waterproofing. Finally, the shower pan receives a white finishing coat using a bathtub refinishing kit. He applies 3 layers to fully seal the surface. Because this product has strong solvent fumes, proper ventilation is essential during application. He cuts a drain hole through the raised floor so it can connect directly to the plumbing system installed below. Precisely locating this hole is critical to ensure it aligns perfectly with the drain outlet of the shower pan. After double-checking the measurements and positioning, the custom shower pan is placed into the bathroom space. Because it was built specifically for this layout, it fits neatly into the compact cabin area, maximizing the available space. Once the pan is positioned correctly, the drain plumbing is connected from underneath, completing the primary installation of the shower base.
To finish the bathroom area, the next step is installing waterproof wall materials. First, he covers the wall frame with a layer of wooden paneling, creating a flat surface that serves as the base for the final wall covering. Next, the walls are covered with fiberglass reinforced panels, or FRP. This material is highly water-resistant, smooth, and easy to clean, making it commonly used in moist environments, such as bathrooms and commercial kitchens. Installing the FRP panels inside the boat presents a small challenge. The lower part of the wall follows the curved shape of the boat hull, so the panels must be fitted carefully along that curve. To secure them tightly, he uses nylon rivets, which hold the panels in place without cracking the material. The seams are then sealed with waterproof silicone and finished with plastic trim pieces to prevent water from getting behind the panels. With these layers installed, the bathroom walls become fully waterproof, durable, and easy to maintain inside the houseboat environment.
Since the bathroom on the boat is only used for about 10 minutes a day, dedicating the entire space to a permanent shower area would waste valuable room. To maximize efficiency, he designs a rotating storage cabinet system installed above the shower pan. In its normal position, 2 storage cabinets swing inward, covering the shower space. In this configuration, the area functions as a storage compartment for everyday items.
When it's time to take a shower, the process is simple. Unlock the steel barrel bolt, rotate the cabinets outward, and secure them in the open position using a window lock. Once rotated away, the entire space below becomes a full shower area. After showering, the cabinets are simply rotated back into place and locked again, turning the space back into storage. To prevent water from getting behind the rotating structure, he installs thick rubber gaskets that press tightly against aluminum edges and the plastic trim of the FRP wall panels, forming a reliable water barrier during showers. Ventilation is also carefully designed. A high-powered 12-volt ceiling exhaust fan removes moisture after each shower. Additionally, a 2-inch ventilation gap above the bathroom door and another gap beneath the door allow air to circulate through the space. Even the rotating cabinet has small clearance gaps of about 1/4 inch, which not only allows smooth movement, but also help moisture escape more easily. This clever design allows a very small space to function both as a shower and as storage, making the most of every inch inside the houseboat.
The next step is finishing the bathroom ceiling. Instead of using new materials, he installs reclaimed wood boards for the ceiling. Reusing old wood not only reduces costs, but also keeps the interior design consistent with the rustic character of the rest of the boat. Once the wooden ceiling panels are in place, he installs several recessed LED lights. The lights are spaced evenly to provide adequate illumination for the compact bathroom space. To make the lighting more versatile, he also installs a dimmer switch, allowing the brightness to be adjusted depending on the situation. This way, the bathroom can be bright and functional when needed, or softly lit for a more relaxed atmosphere. To supply hot water on the boat, he installs a propane tankless water heater, also known as an on-demand water heater. Unlike traditional tank heaters, this system only heats water when it is flowing, making it far more energy efficient. For safety reasons, the heater is mounted outside the boat's hull rather than inside the cabin. Propane tankless heaters like this should not be installed in enclosed spaces without proper ventilation. Before the water reaches the heater, he installs a check valve in the plumbing line. This valve prevents hot water from flowing back into the cold water supply, helping maintain a stable and reliable system. Once heated, the water is distributed to two main fixtures on the boat, the sink faucet and the shower.
With this setup, the compact houseboat now has a fully functional hot water system, bringing everyday home comfort onto the water. To handle sanitation on the boat, he builds a DIY separating composting toilet, a solution commonly used in tiny homes and off-grid living spaces. The main waste container is simply a large plastic bucket. Inside the bucket, he adds a mixture of sawdust, peat moss, and other composting materials, which help absorb moisture and control odors. For easier maintenance, the bucket is lined with a trash bag, making it simple to remove and replace the contents when needed. The system is designed to separate liquid and solid waste. Urine is directed into a plastic funnel, which connects to a separate drain tube. This tube runs through the wall using an ABS pipe, allowing the liquid waste to be directed outside through the plumbing system. To keep the area odor-free, he installs a small 12-volt ventilation fan. The fan continuously pulls air out of the toilet area, helping to remove odors and reduce humidity. With this simple but effective setup, the toilet system requires no water, produces minimal odor, and works perfectly in the limited space of a houseboat. The next step is installing the gray water holding tank, which collects wastewater from the sink and the shower, but not from the toilet. To access the installation area, he first has to cut a section of interior paneling inside the boat. The space underneath is extremely tight, making the installation process quite challenging. At the same time, he installs the freshwater storage system. Instead of using a traditional rigid plastic water tank, he chooses a water bladder tank, a flexible storage solution. This tank is made from 1.2 millimeter thick PVC canvas, holds about 63 gallons of water, and costs around 180 Canadian dollars. The main advantage of this type of tank is that it is lightweight, flexible, and much easier to fit into tight spaces. Once the tanks are in place, he installs the boat's water pumping system. This includes mounting a water pump, connecting the supply lines, and using various fittings and adapters to complete the plumbing network. With everything connected, the houseboat now has a fully functional water system, much like a small home on land.
Next, he begins building the kitchen cabinet framework inside the cabin. Most of the materials used are reclaimed wood or lumber he milled and prepared earlier, with only a single sheet of half-inch plywood purchased for specific structural parts. The cabinet design includes a few interesting features. One of the most notable is the tambour door, a roll-up wooden door made from narrow slats. When opened, the door slides and rolls into the cabinet, making it ideal for tight spaces since it doesn't require clearance for a swinging door. Part of the cabinet is also built with a large curved edge, giving the interior a softer, more organic appearance instead of sharp right angles. The cabinet doors are made from reclaimed cedar boards, salvaged from an old sauna. Cedar is a great material here because it is lightweight, naturally moisture-resistant, and has a pleasant aroma. Once the cabinet doors and drawers are completed, they receive multiple coats of protective varnish. Next comes the kitchen countertop. The wood used is birch harvested from his family's property, which had been air-dried and stored for several years. The boards are planed down to about 3/4 inch thick and then glued together to form a large countertop panel. After finishing the countertop, he uses a jigsaw to cut the opening for the sink, which is salvaged from an old trailer. Finally, he installs the sink and faucet, adds an aluminum edge trim to the countertop, and mounts the cabinet doors and drawers, completing the compact kitchen area inside the houseboat. Before installing the door, the first step is waterproofing the door frame. He mixes epoxy with West System 406 silica filler, creating a thick and durable adhesive. This mixture is used to bond strips of marine-grade plywood around the door frame, forming a raised lip along the edge. This raised edge serves an important function, preventing rainwater from flowing back into the cabin. With the frame prepared, he moves on to building the lower door panel. The lower door frame is constructed from wood and divided into 4 small window openings. Each opening is fitted with transparent plastic panels to allow natural light into the cabin. On the outside of these openings, he installs small foldable wooden panels. When the door is folded down and used as a platform, these panels create a stable stepping surface, and rubber inserts are added to prevent slipping. With this design, the front door becomes more than just an entrance. It transforms into a multifunctional space at the front of the houseboat. The front entrance is designed as a 2-part door system. The lower section folds downward, functioning both as the main entrance door and as a small standing platform at the bow of the cabin. The upper section opens upward, acting like a protective canopy. Next, he starts working on the upper section of the front door, deciding to add a large window opening to bring more natural light into the cabin. The window frame is made from reclaimed wood salvaged from an old piano. To shape the frame, he uses a 5-inch hole saw to create rounded corners for the window opening.
The joints are then reinforced with oak dowels, which helps increase strength and prevent cracking at the corners. The two components are bonded together using epoxy in a three-step process. First, he applies a coat of pure epoxy to the wood edges, allowing the wood to absorb the resin and improve adhesion. Second, any gaps are filled with epoxy mixed with strengthening filler. Finally, he applies a 4-inch strip of fiberglass tape, 6-ounce woven fiberglass, across the joint, making the connection extremely strong and fully waterproof. Once the epoxy cures, he fills small imperfections with Bondo, followed by extensive sanding. Special attention is given to corners and transitions between panels. This step alone takes around 6 hours, with many areas hand-sanded because power tools can't reach them. Before painting, the entire door receives a sealing coat of epoxy. He pays particular attention to the end grain, since these areas absorb epoxy heavily, almost like a sponge. After sanding the epoxy surface, he applies 3 coats of paint, resulting in a smooth finish that almost looks factory-made. For the window, he installs a piece of recycled plexiglass sourced from a local shop. The installation process includes double-sided glazing tape, placing the plexiglass panel, and then applying clear silicone to secure and waterproof the joint. Finally, he installs edge trim with an integrated EPDM rubber seal around the door. This acts as the first line of defense against water, while the raised lip around the door frame provides an additional barrier to keep rain from entering the boat. Finally, he fitted the upper door onto the boat. Because the door was quite large and heavy, he installed 2 80-pound pneumatic struts, along with an additional 56-pound strut in the middle. These pneumatic struts function similarly to the lift struts used in car trunks, helping to hold the door open and reducing the force needed to lift it. To improve comfort inside the cabin, he also installed window blinds. These provide privacy, sun protection, and the ability to completely obscure the view when needed. Several small but important details were also added. He installed latches on both sides of the door to secure it, along with tie-down anchors to help pull the door shut securely. After a few days of adjustment and use, the door will naturally settle into place, and the hinges and gas struts will start operating smoothly, making opening and closing the door easy and convenient. Next, he begins building a custom table for the living area inside the boat. At first, he starts with an old table taken from a travel trailer, but he only keeps the folding metal mechanism because the original tabletop is too heavy and unattractive. This mechanism is very useful because it allows the table to lower down, turning the seating area into an extra bed for guests. He started by cutting a sheet of 1/4-inch plywood as the base for the tabletop. In the center of the table, he uses a piece of old flooring wood that had developed natural fungal staining, which creates a unique and beautiful natural color. The wood is cut into strips about 3 inches wide, and he combines them with mahogany strips to create a striking centerpiece. Then he used leftover Douglas fir wood pieces from previous projects and cuts them into uniform pieces to create a decorative pattern across the surface. Along the edges of the table, he adds thin wooden strips to make the design more detailed. The entire process of arranging and gluing the wood pieces takes several days to complete. Because the initial clamping pressure wasn't strong enough, some areas slightly lifted, so he used a belt sander to flatten the entire surface. To keep the table lightweight while still appearing thick, he built it with a hollow core structure. He adds a second sheet of 1/4-inch plywood underneath, along with an internal wooden frame for strength. He also installs wooden dowels to ensure the 2 plywood layers remain stable and resist warping over time.
The 2 sections of the tabletop are then glued together using many clamps and weights to keep everything perfectly flat.
As a result, the tabletop looks like a solid slab about 2 inches thick, while remaining much lighter.
Small gaps between the wood pieces are filled with epoxy and the entire surface is sanded again. Next, he uses a router to carve out the recess needed to install the folding table mechanism. For the final finish, he applies 4 coats of protective finish, light sanding between each layer for a smooth surface. The edge of the table is finished with aluminum trim, matching the design of the kitchen countertop. Finally, he reinstalls the folding table mechanism and paints some of the metal parts white so they blend in better with the interior. The result is a beautiful, lightweight, yet very sturdy table that can lower down to transform the seating area into an extra sleeping space. Next, he begins building the first seat for the dining area inside the boat. The process starts with creating the seat frame to match the curved shape of the boat's hull. He cuts a 1/4-inch plywood panel following the hull's contour using an angle gauge and a jigsaw, then smooths the edges with a small hand planer. To strengthen the panel, he adds wooden edge strips around it. The panel is then secured to the boat's hull using screws and construction adhesive, which also helps fill small gaps and create a solid connection.
Next, he cuts leftover wood pieces to build the structural frame of the seat. One particularly interesting detail is the rounded corner of the seat. To achieve this curved edge, he needs to bend wood. He cuts the wood into 3 very thin layers, each about 3/32 of an inch thick. The wood strips are soaked and heated to about 250 degrees Fahrenheit for 2 hours to soften them. While still warm, they are clamped into a curved jig and left overnight so they hold their new shape once dry. After drying, the curved pieces are trimmed to the correct size and installed into the seat frame. He begins painting the entire seat frame white to match the interior style of the boat. The white paint helps brighten the space and create a cleaner look while also highlighting the rustic canvas seat cushions. Once the paint dries, he installs rubber edge trim along the frame edges. These strips help protect the wooden edges, reduce friction with the cushions, and give the seat a more finished and refined appearance. Finally, he places the upholstered seat cushion onto the frame, completing the first seat in the dining area. With this seat finished, the interior of the boat moves one step closer to completion.
Next, he moves on to building the remaining seat in the dining area. However, since there is still some extra space available, he decides to add a small countertop along with a storage compartment underneath to make better use of the area. He begins by building the wooden frame for the seat, following a similar process to the previous bench. Wooden pieces are cut to size and assembled into a sturdy frame, carefully shaped to fit the curved interior of the boat and the dining area layout. The storage compartment beneath the seat is designed to hold drinking water. On top of the small countertop, he installs a manual hand pump, which allows water to be pumped directly from the container below up to the countertop. With this design, the seating area not only serves as a place to sit and dine, but also integrates storage and a convenient drinking water system, making the most of the limited space inside the boat. Next, he installs a diesel heater to ensure the boat can stay warm during colder weather. He begins by choosing a location under the small countertop inside the boat. To support the heater, he builds 2 custom brackets and a plywood base. This setup allows the entire heater assembly to be lifted out easily for maintenance or repairs. Then he installs the fuel system. The diesel tank is placed at the stern of the boat to prevent fuel odors from entering the living space. He drills a small hole to route the fuel line into the cabin, positioning the hole at a slight angle to prevent the hose from bending or restricting flow. Once finished, he installs the exhaust pipe through the hull of the boat. He cuts a hole through the fiberglass hull, leaving about a 1-inch gap around the pipe. This gap is then filled with ceramic fiber insulation, a material capable of withstanding temperatures up to around 1450 degrees Celsius, which protects the hull from the heat generated by the exhaust pipe. Finally, he connects the entire system, including the fuel line, electrical wiring, and exhaust, and performs a full test run. At the start of the test, the temperature inside the boat is only about 8 to 9 degrees Celsius, but after just 20 minutes of operation, the temperature rises by more than 10 degrees. Overall, the heater produces heat very quickly and effectively. The only drawback is that it can be a bit noisy, but it still serves as a reliable backup heat source alongside the boat's wood stove.
In the final stage of the project, he continues finishing the remaining details of his tiny houseboat. He completes the kitchen cabinets and interior details, installs all the essential living equipment, and continues refining the wooden surfaces and interior finishes inside the boat. On the outside, he paints the entire exterior, protecting the hull from weather and water exposure. He also adds hand-painted artwork to the outside of the boat, giving the tiny floating home a unique and personal touch. However, the finishing stage takes quite a long time and involves many small steps, so the video cannot show every detail of the remaining work. If you're interested in seeing the full completion of this tiny houseboat, you can click the link in the video description below to watch the entire process.
After hundreds of days of work and thousands of carefully crafted details, the tiny houseboat finally comes to life. From raw pieces of wood to a fully finished structure, every step, from cutting and shaping to sanding and assembling, has been done by hand. What started as a simple construction project has become a fully functional floating home. Inside this small boat is a complete living space with a kitchen, bathroom, sleeping area, heating system, and cozy corners designed for everyday life. What makes this project truly special isn't just the craftsmanship or design, but the patience, creativity, and determination to build something entirely by hand. Every reclaimed piece of wood, every clever space-saving solution, and every handmade detail contributes to a unique tiny home floating on the water. If you enjoy DIY projects, tiny house living, and creative building journeys, be sure to follow the channel and check out more videos like this. Thanks for watching all the way to the end.